Every time that we've used cout so far, we've used it to print out what's called a string. Now, a string is the thing that resides between these quotation marks here. And a string is called such because, well, the most basic component of the string is the character. And a character can be any lowercase letter, any uppercase letter, any number, any quotation mark. We've even seen special cases of characters like this new line character. These spaces between everything here are considered characters. And when you get a sequence of characters together like this, well, it's called a string of characters, or just a string for short. And a string is a type of data in C++. Well, as it turns out, this thing right here can also be called a literal, well, for different reasons. A literal is a data type that is hard-coded and never changes between executions of the program. And so this fits that definition right here. It has the data type string, it's hard-coded, and it never changes. For instance, when we run this program, we get the same string printed out to the terminal each and every time, no matter how many times in a row we run the program, okay? So this is also called a literal. Now, literals are specified by whatever data type they are. So this happens to be a string data type, so you can call this a string literal. But you can have literals of any data type. So for instance, we have another data type that we know of called an int, or an integer. And so we can have integer literals as well. And so let's see one of those in action. We can see out to the screen just the raw number 25. Now notice there are no quotation marks around that number. It is just the actual number 25 there. And when we print that off to the screen, well, as you might expect, we get 25. Now, interestingly, in this case, we can put a set of quotation marks around this and change it from an integer literal to a string literal. And so when we run this now, we get 25 out to the screen. So not much difference between them in this particular example, but we can see in other examples that there's actually a big difference between them. So for instance, we have this integer literal 25, no quotation marks there, and say we add it to another integer literal 5 here. And so basically we want to print out to the screen the result of the calculation 25 plus 5 between two integer literals, and we get the result 30 here. But if we were to put quotation marks around this now, so that we're no longer dealing with integer literals, but we're dealing with a string literal, if we print this off, now we get 25 plus 5 printed off to the screen, not the result 30. And so you can see here that, with the numbers, you can do calculations with them. With the string, it's just a clever sequence of characters that kind of looks like numbers. It's not actually numbers. And so integer literals, it has that capability over strings. You can do math with them. So, but still, they're literals. They're hard-coded, and that's still pretty inflexible. And that's where this thing called a variable comes in. A variable isn't hard-coded necessarily, and it has a little bit of flexibility to it. And so let's demonstrate some variables here. Well, remember back in math class, if you had something like x equals 5, you knew that you had this variable named x, and every time you saw x, you could think in your head, well, x equals 5. And then if you ran across some sort of expression like x plus 90, well, you knew that x was just a placeholder for that value 5, and you can plug that 5 in right here and just equate that in your head to 5 plus 90. And so you see that the answer to this is, well, 95. We also know from math class that variables aren't stuck at any particular value. They can vary over time. And so this x may equal 10 later on. Well, the same process occurs. When you see this x down here, you think to yourself, well, 10 now. And so you see 10 plus 90 is 100 instead of, well, the 5 plus 90 equals 95 that we arrived at earlier. But the same process occurs in C++ when we create variables. You have to name it something like x, and then you have to give it a value like 10, and then you can use it for stuff like solving math. And so, well, let's get into that. Well, the first thing you have to do before you name your variable something is you have to specify what kind of data that variable is, and we're going to use an integer variable since we're already familiar with those. And so say we have this int variable, and we'll name this variable apples. Maybe our program keeps track of how many apples we have in our basket. Then you have to assign our apples a variable some sort of value. Say we have 5 apples in our basket, so we can say apples equals 5. And now you can start using apples for stuff. So maybe we see out to the screen, I have, and then we'll say apples. Now notice I'm not putting any quotation marks around this. And we can finish this sentence, say apples in my basket. Now, what's going to happen here, because I didn't put any quotation marks around apples when I typed it out in the middle here, is that we're going to call up the value that is stored within apples here. And so the sentence is going to read off, I have how many apples? 5 apples in my basket. And I'm going to drop down a couple of lines. If I put in quotation marks around this, it would have just simply read, I have apples in my basket. So that's the difference between a string literal in this case and just using the value that's within a variable. So once again, when we run this, we see that I have 5 apples in my basket. Now I can change this value up here to be something else because remember, variable values can change. Now notice I didn't change anything in the code in this particular sentence. All I did was change the value that was stored in apples. So now this is going to read, I have 100 apples in my basket. And I didn't change anything in this entire line of code right here. Just the value that was stored in the variable. And sure enough, I have 100 apples in my basket. So that's pretty cool, huh? So that being said, this is in a nutshell how you use variables in C++, but there's a couple of other things that I want to go over, little nuances. First of all, you can name your variable anything that you want to within reason. There's a few rules to this. The first big one is that you can't name your variable any keyword that's already reserved in C++. Like you can't name your variable using or main or namespace or include or anything like that. It's got to be your own unique word that C++ doesn't already use for something else. All right, that being said, the first character of your variable has to be either an underscore, a lowercase letter, or an uppercase letter. That's the only thing that your first character can possibly be, one of these things. Now, any other character in your variable name can be an underscore, a lowercase letter, an uppercase letter, or a number. It never can be any sort of punctuation marks or anything like that. These are the only characters that you can use right here. These are the ones that you can use for your first. After that's taken care of, these are the ones that you can use for any other character. So just for instance, to show you the difference between those two, you can have bag1 as a variable name. That's fine. You can have numbers in there. They just can't be the first number. So you can't have one bag. That's illegal because it begins with a number, and you can't begin your variable with a number. Now, you can get around this by having underscore one bag. Well, because technically the first character in your variable name is an underscore, and that is allowed. All right. So that being said, there's one other thing I want to point out. This thing right here is called an assignment operator. It looks like an equal sign. For the most part, it even works like an equal sign, but there's one big difference. There's directionality to how this operates. Basically, remember in math that you can take a statement like x equals 5 and 5 equals x. And both of those things are valid. Those are equivalent statements. Well, when we're creating our variable here, it has to be in this particular order. It has to be apples equals 100. You cannot say 100 equals apples. And the reason being is the way this assignment operator works behind the scenes. Basically, it takes whatever is on the right and assigns it into the thing that's on the left. Well, why does that matter? Well, let's think about it a little bit more in depth here. The thing on the right is this hard value. It's 100, right? And we're assigning that hard value into the thing on the left, which is a variable value. So apples can be anything. Apples could be -1, it could be -3 million, it could be 7 million, who cares? Apples can be anything. So you can assign 100 into this value here because, well, this is a hard value and this is a variable value. This value has to be 100. This value doesn't. This value can be anything, including 100. It can be anything. So you can make this 100 go into apples, but it doesn't make a whole lot of sense to take this variable value that can be anything and assign it into this hard value that can only be 100. See what I mean? There's a difference there because of this direction. It always takes the thing on the right and puts it into the thing on the left. And so this statement wouldn't make sense like that. And we can even see that if we try to run this. C++ doesn't like this line. So let's get rid of that. Now, one other small thing that I sort of want to point out is that you can actually do your declaration of the variable when you do this, say int apples, and your assignment statement where you give it a value all in one line. This is also valid. You can say int apples equals 100. And you can save a little space in your programming. These two things are the same. This one just does it in 2 lines, splits up the tasking. This one puts all the tasking in a single line. All right, so that's all I'm going to talk about variables for now. We'll definitely bring up some more nuances about this later, but I want to introduce you to variables because we're about to start doing math. All right, see you in the next one.